Good day, ladies and gentlemen. This is Sarah van Grenen, aka Mr. VG, and this is a beautiful, beautiful, beautiful day to do mathematics. In this specific question, we are looking at logarithmic graphs. Now, logarithmic graphs are fantastic, fantastic graphs, but unfortunately, teachers tend to just brush over it and just quickly move on. And then you guys hit the exams, and then you're like, what? I didn't know I needed to know half of this stuff. So I'm going to take you step by step by step as we work through question 6 of the November 2021 Department of Basic Education Mathematics question paper. So my little bit of advice to you is hit the pause button at this time and do this yourself first. Go for it. When we look at question 6, now question 6 is a lovely question, okay? It has some small little intricate things that we need to know of. So I'm going to start by analyzing that graph of y equal to log 4 of x, or f of x equal to log 4 of x. So when we look at that question, what can we actually read off? I think you are starting to kind of get a general feel for the way that I answer any math question. It's before I actually look at the question, I look at the information. But for this, you have to know your theory. First of all, there are restrictions when working with logarithms. That x, or whatever is inside the log function, must be positive. So in this case, it's just x. So x must be greater than 0. But this then leads me towards, what does the base tell me? If the base is bigger than 1, now it's kind of an interesting thing. As y goes from lowest to highest, my graph goes away from the asymptote, okay? So as y goes from lowest to highest, your graph goes away from your asymptote. Interesting, hey? Very, very interesting. But what if I don't have that asymptote, okay, explicitly? Well, actually, you do have it, because in your graph, or in your function actually, we know x must be greater than 0. So that where it's equal to 0, that is your asymptote, okay? So where it's equal to 0, that's your asymptote. Now I want to ask you, if I've got y equal to log a of x, but a is now smaller than 0, how would the graph look? Maybe you just need to think first. Whoa, stop, think. What else do we know about a? A must also be larger than 0. Remember that both your base and that inside function has to be positive. Now, if a is smaller than 1, then as my y values, sorry for making that, as my y values increase, my graph goes towards the asymptote, okay? Little bit different from if a is bigger than 0. And I know I'm going into a lot of detail, but I want you to understand this. So if I look at this now, I feel like I'm ready to answer the question. But let's see what is next. What if I think about f accent of x? Now you might look at this and go, but so we haven't done, derivatives of logs. No, you haven't. But f accent x is greater than naught. Why is this? Because f is increasing. Your graph increases. As x increases, the y values increase. Hence, f accent x is bigger than naught. We can ask this of you, so please just be aware of it. Even though you can't mathematically derive it at school level, you can derive it using university level maths, definitely. But you must be able to interpret your graphs. So let's now actually go and answer this question. If I look at this graph, the first question is calculate the value of k. So starting with fx, because it has to do with fx, my question is, what makes b so special that we ask it of you? Nothing else except what is actually given in the information, that b lies on fx. So in other words, it's a set of coordinates, which means f of k is equal to 2. And in layman's terms, if x is k, then y is 2. So I'm going to go to my fx. I'm going to make x k and I'm going to make y 2. But for me to actually answer this, I've got to remember how to rewrite from logarithmic to exponential form and vice versa. So if I've got a to the x equal to y, okay, that maybe went a little bit fast. So let's backtrack a little bit. If I've got a to the x equal to y, okay, and I want to get x alone, I'm going to take the x to the other side, and I am going to say, well, that's x equal to log. Your a is the base, so it remains the base, but the y value goes into the log. I like to call that the circle method because it kind of forms the circle. X goes on its own and y goes into the log, but the a remains the same. Now, if I reverse this, I'm literally going to say that y goes on its own and the x goes into the exponent. So if I'm going to apply that to my log, then I'm going to say, okay, the k is going to go on its own and the 2 goes into the exponent. The 4 remains the base. In our sum, this means that k is equal to 16. When I go on to question 6.2, remember to write this in on your sketch. So when I look at question 6.2, now I'm asking you, where is the y value between -1 and 2? So if I go to my graph and I draw 2 lines, one for y equal to -1 and one for y equal to 2, I get this on my sketch. So I've got y equal to -2 and not y equal to 1, peanut, y equal to -1. My apologies, silly mistakes, but at least I fixed it. This means the question is asking for values of x. So I need those x values. The x value for the 2 I've got, but I don't have the x value where y is -1. So I need to get that because that's going to tie into my answer. So when I now get that, I'm going to follow the exact same procedure as I did with finding k. So I'm going to substitute y with -1. I'm going to rewrite in exponential form, and I'm going to solve x. So x is a quarter. Let's write this in on a sketch. So the question is, where is the y values between 2 and negative 1? So this means the x values as well must be between negative or between a quarter and 16. Now remember, I use the equals to because they gave it as equals to. I use the square brackets because they say that at the x value, the y values, actually touches negative 1 and 2. So that's why I use the square brackets. Sure. Let's go on to question 6.3. Now question 6.3 says, write down the equation of f to the negative 1. So what is f to the negative 1? Well, that's the inverse, and it's written there in black and white, but I want to highlight that for you. So in other words, x becomes y and y becomes x. So let's do that swapperoonies and swap your x and your y. But now they do tell me in the form y equal to. So I need to get y alone. So I'm going to say y is equal to 4 to the power of x. Ta-da! Simple and straightforward. Let's have a look now at the next question. Question 6.4. Now, question 6.4 relates in a very, very weird way to x and f to the negative 1 of x. So what I'm going to do is I'm going to do it the traditional way for me, which is drawing a graph. So I'm going to first draw f to the negative 1 of x. So I'm going to look at, how does f to the negative 1 of x look? Well, I do know that f to the negative 1 is actually y equal to 4 to the power of x. Remember, I got that in 6.3. See how 6.3 leads me to 6.4. And we love to ask this, matriculants. 6.3, then 6.4 is being led by 6.3. So let's draw 4 to the power of x. Now I know this because this is a normal exponential graph. But now let's interpret. When is something times by something smaller than naught? In other words, a negative. Well, I'm going to have a positive times by a negative or a negative times by a positive. So look at my colors that I use. I use the x values as red and the f to the negative 1 as that very dark blue. If it looks like black or green, I forgive you, but it's a very dark blue. So I'm going to interpret the x values with a red color. So on the negative side, so when x is smaller than naught, I've got negatives. When it crosses 0, my x values become positive. F to the negative 1 is all positive because I'm just looking at the y values. Now all of the last little bit, let me rewind my screen a little bit. So if I first just backtrack and say, where does the positives come from? Because I'm looking for the y values of the inverse. Now, on the left of 0, I've got a positive times by a negative, so that works out. On the right-hand side of 0, I've got a positive times by a positive there. Is that what I'm looking for? No, it isn't. So in other words, that's not what I'm looking for. So this means that on the left-hand side of 0 works out. So I'm going to write that as my answer. X must be less than naught. Or in interval notation, I could simply say x must be between negative infinity and 0. Again, using round brackets because I don't say equal to 0. But what if I don't want to draw this? Remember, your 70s, 80s, 90%ers look at two different options. So if I look at the second option, which is algebraic interpretations, this might just go over the head of some of you guys. So if you can do it graphically, go for it. But I could go and say, well, what do I know about f to the negative 1? Well, that is 4 to the power of x. But 4 to the power of x is always positive. Look what I did. I substituted the equation into the expression, into that inequality. I substituted the function into the inequality. But 4 to the power of x is always positive. How do I know that? Well, if I make x 5, that's 4 to the 5, which is positive. If I make x negative 5, so understand what I'm doing. I'm just playing around with x values as an explanation. If I make x to be negative 5, remember then I'm sitting with 4 to the negative 5. Now that is 1 over 4 to the 5, which is still a positive value. So I'm just explaining that 4 to the x is always positive. And I look at the graph and I see that 4 to the x, there's always a positive on the graph. So for me to get a minus times by a plus to get a negative answer, it means that that x has to be a negative, because that's the only way you can get a negative times by positive to be smaller than 0. In other words, x must be smaller than 0. But wait, sir, that's exactly the same answer I got there. Exactly, matriculants. Whichever what method you use, that is your choice. But have two alternatives for those of you looking for your distinctions, because you never know which one is going to be needed for the exam. Wow, I love mathematics. So for those of you that have stuck with me in this specific sum, congratulations. I'm looking forward to going into our next sum, which is also going to be about parabolas and straight lines. Oh, it's going to be awesome. So this is Mr. VG signing out. Have a beautiful and amazing rest of your day. Don't do too many irresponsible things. No, I'm joking. Don't do any irresponsible things. Not this time of the year. You need to focus now on getting the results that you can get. This is me signing out. Have a beautiful evening. Keep safe, keep warm, and thanks for tuning in. This is me signing out. Cheers.